Hello, I'm Miss Miller. I tried to take one of your little intros where you play a song. Alright, well, that was brought to you by Willow Smith. Whip My Hair. Today, let's get started on the hair screencast by Erik. Okay. For the skin layers, there's 3 main things you need to know, but, I mean, we're just going to be sticking with the epidermis. This very top layer is the epidermis, and that's the visible part of your skin. Right underneath that is the thicker dermal layer, and then under that is the hypodermis, and that it's kind of iffy because it's filled with a bunch of fat cells. Now let's dig a little deeper, deeper in the skin. Back to the sebaceous glands. The sebaceous gland is a gland in the skin of mammals that secretes an oily substance called sebum, or sebum. Sebum is an oil produced by the sebaceous gland that lubricates the skin and hair. So, what this sebum does is, in the little hair pores, before it comes out, it just slides through this nice and oily substance, and that's what gets my hair so luscious, you know. I mean, you get the picture. I mean, look at this stuff. Thanks, sebaceous glands. Alright. Now, over here, we're hitting up the sweat glands. Now, there's 2 types of sweat glands. There's eccrine sweat glands, and those aren't really aimed at the hair follicles, it's just kind of off on its own. These are located all around the body, and they're used for temperature control mainly. And then there's the apocrine sweat glands, and then that's kind of what you get when you're nervous, doing a presentation, you know, playing badminton, you know. But the main difference here, or not a main difference, but a pretty big difference, is that the apocrine sweat glands are concentrated in certain areas, kind of like the armpits and then the face. I mean, you get the picture. Alright, now we have the papilla, and it's weirdly bolded, but hey, it's fine by me. Alright, the papilla is the part of the hair the hair itself. It's the very end that connects it to the end of the dermal layer. And when you pull it out, I don't think I can get one, but when you pull out a strand of hair and you get that little hair follicle, the papilla is on the very end of that, if you get the full thing. Now, down here, we're at the capillary. I had a hard time with this one, but from what I came up with, it seems like they're little, I think, veins, because it's sending it out. But these capillaries are going through, depositing blood and nutrients to the dermal layer, and then that provides the hair with the nutrients it needs to grow healthily. Yeah, as you can see here, it's kind of embedded throughout the dermis, with the main arteries and veins. Not main, but arteries and veins going through the, I think that's the hypodermal. Yeah, and it enters through the bottom and then kind of spews stuff out there. Alright. Parts of the hair. This was my favorite and the most interesting. The medulla is the innermost layer of the hair, and that's what can make it be straight if it's a continuous medulla, and that means it has no breakages. If it's non-existent, like someone I know. Get it? Because okay, you're one of the few of the proud. Alright, the cortex is it's the area around the medulla, and that's where your pigment's stored, and that's kind of what's going to lead to the coloration of your hair, mostly. And then lastly, the cuticle, it's the outermost layer of the skin, it's the visible part. And then up close, actually, it looks really frayed and you can see all the damage, so I thought that was really cool. I never knew that. Alright. Now, differences between human and non-human hair. Alright. So, there's pigment, and then, you know, some of that pigment in the cortex, it's more, in humans, it's more dense in the cortex, and then for animals, it's more dense in the medulla. So that animals have it more kind of concentrated inside of the middle shaft of the hair. Now, for the hair colored patterns, I don't know about you, but I mean, I don't want to wake up the dog, but it's got some like black and white splotches. But I mean, you're not gonna see me with some black and white splotches up in my hair. So that's a unique trait that animals have over humans. And the medulla, the medulla for animals is much thicker than the humans, proportion-wise. Yeah, and then this is a little cool table I found. I mean, the quality's kind of bad, but bear with me here. Get there. Okay. Alright. Here we go. Alright, some other differences are the, you know that outer layer of hair that I mentioned before? Well, for humans, it's more imbricate, and then that's kind of what you see on the, it's kind of scaly and layered, and that's what you find on the commercials. That's where I'm familiar with them from. And then, well, animals are spinous and coronal. Yeah. And then here's some examples here. Yeah, look, see this rabbit? No. Yeah. Alright, there we go. Alright. Now, alright. This brings me to the case study, the murder of Leanne Tiernan. In August 2001, a man walking his dog in Lindy Woods near Otley in West Yorkshire found the body of 16-year-old Leanne Tiernan buried in a shallow grave. This was about 10 miles from her home in Lanshire Mount, Bramley, Leeds. She had been walking home from a Christmas shopping trip with her best friend in November the year 2000 when she disappeared. So the case itself, what happened was she went out and then she got abducted, and then when she was found, okay, she went missing in the year 2000, the month October, but after the body was found much later, they concluded that it was not initially gone, but before it had been dispatched into the grave, it was frozen into I believe sub-zero temperatures. Yeah, thanks to the help of our forensics pathologists. But ultimately, the demise of the case is, well, she went missing, and then she was found wrapped up in a bunch of garments such as plastic bags, a dog collar, and cable ties. Now, these dog collars and cable ties, or dog collar, you know, alright, it was all traced back to one guy, so that was really helpful for the forensics leads. And the convict was found to be John Taylor, thanks due to trace evidences. Yeah. Well, I'm not going to tell you what time it is, but